Hello everyone, welcome to Datafuse Analytics. In this video, we will learn how the actual training takes place in Generator and Discriminator components of Generative Adversarial Networks. I have done an extensive research and tried my best to simplify this complex topic. In the previous video, we saw architecture of GANs using an intuitive story along with its history and the research paper. We got to know that there are two major components of GAN. One important component is generator and another important component is called as discriminator. I strongly recommend you to spend 5 minutes watching the first video on GANs to understand the concept end to end. Now let's start today's session of training generative adversarial networks. First, we will see the training of discriminator. Now this discriminator is similar to that of an image classifier. Hence, we will treat this problem statement of discriminator training as a supervised machine learning problem. It has to tell whether an input image is a fake one, that is, it is generated by a generator, or the input image is a real one, that is, it is from original dataset. Now, in order to train this discriminator, we must have an annotated training data. Here 0 will represent that image is fake and 1 will represent that an image is a real one. Now we already have real images from original dataset. We can focus on grayish portion for now where the gold labels are ones and predictions are represented with this probability. These predictions are coming from discriminator. Now the loss that we will be using is binary cross entropy. To generate fake images data and to annotate them as zeros, we can use generator for this purpose. So in this way we have solved the data generation problem for discriminator by using generator to generate fake images and using original dataset which will represent original images. So in this fashion the discriminator will be trained end to end just as an image classifier. Now let's move to the training process of a generator. Here the most important point is we need a technique to score the image which is generated by this generator. Fortunately, we have the discriminator to get this score. Now by passing a batch of images through the discriminator, we can get scores for each and every image. The loss function for generator is binary cross entropy between these probabilities and a vector of ones. This helps to train the generator to produce images that the discriminator deems realistic. Here the important point to note is that we want to train the generator to produce images that the discriminator thinks are real. Now let's focus on few key points. The first important thing we have to note here is we need to train these two networks, that is generator and discriminator, in an alternate fashion, ensuring that the network weights are updated one at a time. For instance, during the generator training phase, only the generator weights are updated. If we update the discriminator's weights too, it would adjust to predict generated images as real, which isn't what we actually want, right? The goal here is the generated images to be predicted should be close to 1 because the generator is strong, not because the discriminator is weak. So that's it guys with respect to training of generator and discriminator in generative adversarial networks. If you find this video useful, please share it with your data enthusiast friends and like this video and subscribe to the channel. Bye bye and take care.